Good evening, dear students. Today we are going to learn another important property of carbon called functional group or carbon as a versatile element or carbon is very friendly element. So why carbon is very friendly element? Why it is called as versatile element? Those things we will understand. So there is another important property or inherent to this called functional group. So what is this functional group? This functional group gives the characteristic of versatility or gives the friendly nature for the carbon. So let us start with functional group. What is this functional group? So functional group, the term functional group is simply mean the group means the group of atom, or it may be the single atom also or single element also, which decides the function. It simply means functional means what? That decides the functionality. Functionality means the characteristic. So write about the functional group. What is this functional group? So functional group. A student, in chemistry, group always means it is the a single atom or group of atom. So it is atoms, that is maybe your one atom or group of atom. So it simply means that. So in chemistry, the term group always means the group of atom. So it is nothing but it is the group of atom or single atom. Example, we may consider, say, chlorine or bromine or fluorine or iodine. All of these are denoted by the single symbol X, and it is called as halogen. Another, if we consider the group of atom OH, like OH minus we were learning in our inorganic chemistry, but here the for the carbon is always forming covalent compound. So this since carbon is always forming the covalent compound, so this OH minus is not written, rather it is used as a bond or open bond with OH. Okay, why? This denotation is for ionic, this denotation is for covalent. Similarly, the collection of atom like carbon, hydrogen and oxygen with one bond open. So this is the other group of atoms. So these are the group of atoms or even a single atoms. Mean the functional means that decides its characteristic, means functionality. What is your function? Means what is your task or what is your characteristic? It simply means. So it is decides the functionality or characteristic or feature. Okay, or simply nature. Means what will be the characteristic that will be decided by the group of atom. So that group of atom is called as functional group. Means these group of atom have to be associated with the other carbon atom to give its functionality. So right. So nature deciding. Means these group of atoms when combines with the other carbon chain, then it decides the characteristic of that particular compound, deciding when attached with a carbon chain. Carbon chain or a ring. That is, it simply means that. So functional group here means the group of atom that will attach with the other carbon atom to form a molecule or the compound or organic compound, and this group of atom will decide the characteristic of that compound. Example, a student, if we consider the C2H6, just for simplicity I am considering. How is the structure? The structure is like CCHH H, 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 H. It is like this. But in this, in place of one hydrogen, if I am putting a chlorine, means one of the hydrogen is replaced by the chlorine. C2H5 means hydrogen 5 will be there, then one chlorine will be there. Last day we have learned this chlorine can be kept at any of the bond or any of the position. All are identical. Means all these bonds are identical. I can place the hydrogen at any of the 5 and chlorine at one of the bond. Then will these two compound exactly same or will it different? Then it is found that this compound, new compound, is entirely different from the first. So one may consider this as the first, this as the second. Let me consider one more. In place of this H, C2H5, another group of atom OH is attached. This OH, I have written like this. This OH being replaced for the one of the hydrogen. The 3, for this if we draw the structure will be like this. The remaining 5 will be filled with the hydrogen, and at this one place OH. OH is the group of atom which will always link. This O and H you cannot separate. Okay, here it is this one. So in this case you will find that this OH group is also entirely different from the second, means chlorine. This OH containing compound is also entirely different from the C2H5. So what makes this difference? From 1 to 2, here we are getting this chlorine means Cl. This atom is the deciding factor. So this Cl. But coming to 1 to 3, here we are observing that this OH, this OH is the deciding factor for the characteristic of this molecule. So that's why here we are observing these are the atoms of group of atoms which decide the entire characteristic. A student, if I write the characteristic of few of them, then for first it is simply the alkane. Okay, all contain the carbon hydrogen bond only. This is called as, the second one is called as chloroalkane, or this is called as chloroethane ANE. This is the chemical name. The third one, if you consider this, then the name is your eth. Here it is ethane, chlorine is taken before it, but for this is our ethane, but OH is deciding factor. So to include this OH, we are using the group name called alcohol. So therefore this group or this group of atom which decide characteristic is called as functional group, and if the group is of oxygen and hydrogen acting as OH, it is called as alcohol group. Alcohol group. But if in place of this OH, if we are taking only chlorine, Cl, it is called as chloro group. Chloro. Or maybe fluorine or bromine, so better term is called as halo group. It is this one. Get it? This C2H5, which was alkane, but alkane may be methane, ethane, propane, butane. So the name for this alkane is our ethane. 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 So here we are observing this ethane gets converted into chloroethane if one of the hydrogen is replaced by chlorine group, means Cl. This ethane gets converted into alcohol group if we replace one of this hydrogen by OH minus. Means what we are observing that this group Cl and OH, these are the group of atom that decides the characteristic of this entire molecule, irrespective of the remaining, I mean this carbon chain. Getting? Irrespective of this, here we are getting, in every cases the remaining part are identical. Remaining part are identical, but this Cl have given different characteristic. So this chloroethane is used as organic solvent in our laboratory. Okay, used for making various, I mean polythene and other kind of things. This alcohol, you are already knowing, alcohol is used as or used in many medicine. So this ethanol have medicinal characteristic, medicine, even as beverages or for the drinking purposes. Not only that much, also used in petroleum as additive. So along with the petrol, 5% of alcohol is added to increase its efficiency. So as medicine and additive to carbon fuel, but chloroethanol, it is used as solvent in lab. It is basically the non-polar solvent. This ethane as the gas, okay, like methane, ethane, propane that we are knowing in our LPG. These are some of the constituents. So this is the gas. But if you consider this chloroethane, it turn into liquid. How from the gas it turn into the liquid? This conversion of gas into liquid is because of the presence of chlorine. This chlorine gives the characteristic to get converted it into the gaseous phase, from the gaseous into the liquid phase, which is used as polar solvent in our lab. And if OH is there, OH group is there, or alcohol group is there, then it is used as medicine and in petroleum. Okay, so this way we are observing this Cl, OH. These are the atoms or group of atoms that decides the characteristic of entire molecule, irrespective of their other carbon chain. So that one, the definition of functional group is like this. So this I was explaining. So group is the group of atoms that decides the functional or characteristic feature irrespective of their carbon chain. Whatever the type of carbon chain present, that is not deciding. Like here we are getting everywhere 2 carbon and other hydrogens are there, but it is the chlorine and OH minus which decides the characteristic. Okay, students. So let us write for the definition. Again and again camera is getting off. So write down the definition of functional group. Definition are very important. Functional group. So functional group simply means these are the atom or group of atoms. Okay, student, it may be the single atom like chlorine we have observed, or it may be the group of atom like OH minus. There are many more like CHO, like COOH. Many more are there. So these are the atoms or group of atoms which decides the characteristic of that molecule. Right? Atoms or group of atoms present in any organic compound present in an organic compound which decides or determine or sometimes only gives word is also used, sometimes dominate word is also used. So whatever the term is used, so atoms or group of atoms which decides or determine the feature or characteristic, the characteristic or feature, or rather many a time nature. What will be the nature of that, or what will be the characteristic of that organic compound? It will be decided by the group of atom, is certain, only certain atom or only certain group of atom, not by the entire carbon chain. Atom or group of atom present in an organic compound which decides or determine or gives the characteristic or nature of the compound is called functional group. Okay, student. Example, take the functional group. Say I'm taking propanol. Say the word or the organic compound given is propanol. If you draw the structure of this, how is this? How is to draw this structure and how is this name? We will discuss in our next class. Propane means it must contain the 3 carbon. you have to fill the valency. Here OL tells it contains a functional group which decides the feature, and that is our alcohol group, and it contains one OH, this one. So propane, so from propane one of the hydrogen is being replaced by this OH, like we were discussing earlier for ethanol. So it is our C2H5. In place of C2H5, accordingly we need to increase this. It become like our C3H7OH, or simply written like this, C3H7OH without this bond mean the same, or even with bond written it. So both are the same thing. For drawing the structure, you are getting the 3 carbon. At 7 places, you have to fill with the hydrogen, and at one of the place, there will be OH group. Are you getting? It is this. So it is this group of atoms that decides the characteristic, and it is different from the propane, C3H8, and it is found that it is alcoholic, means the alcoholic characteristic is present in this. So alcohol. Ready? So there are certain atoms or group of atoms that decides. If we are writing the chloropropane, say, a student, you may draw the other structure also. For that, the isomers that we have learned, that characteristic also arises here. One of you may draw like this, carbon, carbon, carbon. Then for satisfying the valency or tetravalency of carbon, one may put the OH here. All others satisfied by the hydrogen. It is also correct structure. Okay, this is also the alcohol, and these two are your isomers. These two are isomers because of change in position of functional group. It is this one. Get it? Maybe possible that there is only one atom which decides the entire characteristic. What is that? Let me draw that one also. Let us consider the second one. Take this. Say chlorobutane. A student, how this name is given, that we will learn later. So first you have to draw the butane, and one chlorine atom is there. So butane, normal formula for butane is C4H10. So one of the hydrogen have to be replaced by the chlorine. So the formula for chlorobutane is like this. So it is C4H9Cl. Okay, from this butane, this chlorobutane is obtained. The structure you may draw 3, 4. Everywhere you have to fill the tetravalency, and one places you can put the chlorine. Now you are also free to put the chlorine at the other places. There, by that you may also get the isomers, like chlorine means carbon, 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 the 4 carbon. For finishing the tetravalency, if anyone is putting the chlorine here, it will give a different structure for the same molecular formula, and this new structure is the isomer of the first one. Even if you are putting this chlorine here, you will not get the new structure. Okay, student? This we have learned last day. But some of you may think, no, rather than a straight carbon chain, one may draw the 3 carbon chain like this and the 4th carbon here. Okay, means splitting from here and interchange with this hydrogen, you will get the new structure, that will be the other isomer. So fill it. You can put the chlorine at any of the carbon. So even if you are putting the chlorine here, you can get this isomer. The other isomer that you can draw is this one also, where chlorine, here we are getting the chlorine is placed in at the middle carbon, but one can put the chlorine at any of the terminal carbon. So let me put the chlorine. Whether you put the chlorine here or in place of here, whether you are putting here or whether you are putting here, all mean the same thing. Okay, but not here. So let us put the chlorine at one of the terminal, any position. So let us keep this chlorine here and fill all the other valency by the hydrogen. How this is structure we are drawing, last day we have discussed in much more detail. Please go through those videos. So what we are getting? This way we have obtained 2, 3 and 4. So these are the 4. So total 4 isomers. But all of these are chlorobutane. All of these have nearly the same characteristic. They are slightly different. Okay, it is this one. So how to name it, how this is different from the other, that we will learn in our next class. But for your understanding, you can just understand that wherever the chlorine, from that carbon you start start the numbering for the carbon chain. 1, 2, 3, 4. Here chlorine is present at 1 only. You shall not start numbering from here. This is the rule that we will discuss in our next class. How to name an organic compound. So this chlorine is present here. Position of chlorine is written first. So 1 chloro, and the longest carbon chain that we have drawn here is the 4. So it is our butane. If we consider this one, here we are getting this chlorine is present from which end? From this end. Say from right end, 1, 2, 3, 4. But if any of you are numbering from the other end, say from this end, 1, 2, 3, 4, then always there is an ambiguity whether 2 or 3 should be taken. Then it is accepted, or in the nomenclature one rule is there, wherever you are numbering, the smaller number you have to prefer, and that you have to put before the chlorine. So the name of this will be our 2-chloro. Chloro is used as prefix. What are these prefix, suffix? Everything we will discuss in our next class. Butane. The carbon have 4 chain. Now coming to this, if you want to write, in this case the longest chain we need to consider. One may consider the longest chain like this. 1, 2, 3. The carbon chain should always be a straight one. One may number from 1, 2, 3 this way. Always it is coming as 2. One may also think that the chain should be taken like this, because turns are not taken as branch. And even if you are starting with this 1, then 2, then 3, I mean from this terminal 1, then 2, then this 3, still you are getting the 2. The same. So in this case we have to keep in mind the other means the chain is of the 3 length, but one of these is taken as another prefix. It is called as methyl if we are considering the chain is like this. Okay, or even if you are considering the straight chain, then this will act as the prefix as methyl. More detail we will learn tomorrow. By that you are able to understand everything very easily. So student, I am considering here the straight one. For a straight one, the numbering can be from any of the places. You are always getting the 2. And this is taken as another methyl. So how is the name? 2 chlorine is there, and this group is called as methyl from methane. Methane is our CH. It is methane. But if one of the hydrogen is removed, if it is like this, hydrogen with this attached with other carbon or left as it is, this much part is called as methyl. Okay, this is our methane. This thing we have done earlier also. So the name is like this. So at 2 position we are getting the one of the chlorine is there, and also at the same position number 2 we have the methyl group also. So it is written as 2 chloro 2 methyl, and the carbon have how many? Sorry, the chain have how many carbon? 1 2 3. Propane. Here we are getting, it is, though the formula wise it have 4 carbon, 9 hydrogen and 1 chlorine, but giving the name it is called as propane. But in common name it is called as chloroisobutane. So there are certain ambiguities, so common name are not kept in mind. So IUPSC nomenclature is preferred. In common name it is butane, but in IUPSC name it is propane, and this is the preferred. If we are considering this one, here again we are getting, we shall number from here to here, 1 2 3, then this is acting as another methyl group. Or the other way is, you can take the straight chain also, means from here to here. Always from the functional group you have to start the nomenclature. That's why I am discussing the functional group first. 1 2 3, but here this is acting as the methyl, so the name is like our 1 chloro 2 methyl. This number you have to put, and the longest chain have the 3, it is called propane. So here we are getting total 4 isomers are possible. Though all the isomers have the same functional group, the functional group here is the chlorine. So this chlorine is the single atom which decides the characteristic, and in the first one OH is the functional group which decides the characteristic, give the characteristic of alcohol. But the second example we have taken is not the alcohol, it have entirely different characteristic called chlorobutane characteristic. So this second one is acting as a solvent, and also in medicine and many other places. So what we have learned here, the functional group is nothing but it is the group of atoms which decides or determine the characteristic of a given compound is called functional group. So what are different functional group that I am going to list? And also here we are observing, if the functional group is there, then a specific name is attached with it. So how is this nomenclature? This suffix I will only write. So either this functional group is added as suffix or as prefix. Here prefix which is coming before the name, suffix which is coming after the name, like propanol, OL at the end, it is a suffix. Like here I have written chlorobutane. Chloro is coming before the name butane, so this chloro is our prefix. So students, this functional group are indicated in the name by adding either prefix or the suffix. This is our suffix. So which one group is added as prefix and which one is added as suffix? This thing we will also list. So another table I am just going to write, and that table will be helpful throughout this chapter. So write this: various functional group, what is the structure of this functional group, means what is the formula for this functional group only. Okay, so its structure, in naming, how it is named, whether as prefix or suffix, by adding which alphabet in that. Like here I had explained, if alcohol OH is there, I need to add suffix OL. If there is halo group, then add it as the prefix. A student, we will see more. Say, here we were considering for OH, I have this O and H. For chlorine or halo, as Cl or as X. But here this open valency or the bond, here we are representing by 1. But it may be possible that there could be 2 open bond to attach with carbon. So this is always attached to carbon. It is attached to carbon chain. But there are some other functional group which have more than one such bond ready to attach with carbon, and that one is our ketone that we will see. If the group of atom is like CO, that is, then it is found that this C and O, CO have 2 open bond to attach with carbon. Get it? So this CO is, you may call this as the divalent functional group. So this CO, writing as C and O with 2 bond, it is indicated by putting the 2 bond here, this way, and it is called as ketone. Okay, so this functional group need not always have the single bond. It may have the 2 or even the 3 also. Mostly 1 and 2 are more common. So let us write all those things. So what is the structure of the functional group? That I will write. What is the name? How it is named? And then their example. Some of the example I will take. By this way, we can understand it very easily. A student, the very first, if the carbon contain only single bond, that is called as alkane or the simplest hydrocarbon. But if it contain double bond or triple bond or any other atom or group of atom other than hydrogen and carbon, then the characteristic get changed. So that change characteristic arises because of certain atoms, those or group of atoms or bond, they are called as the functional group. So what they are? The very first or the simplest one is called as the halo group. Halo. It is halo means it is halogen. In carbon compound we will learn the group below the inert gas means 17th group is called as halogen group. So it is halogen or halo. It is denoted by X1. Okay, so how is this? So the structure is like the X. Means one of the halogen atom we have learned, it could be the fluorine, it could be the chlorine, it could be the bromine, or it could be the iodine. But this fluorine, chlorine, bromine, iodine need to form covalent bond with the carbon. That makes difference from the NaCl or other electrovalent compound. That we have to keep in mind, students. So this, if the structure is F, means fluorine atom is only there, the name is starting as prefix. So the name given as the prefix, right, is as the prefix, the word halo is used, not the halo. Like if the chlorine is there, it is called as chloro. If fluorine is there, it is called as fluoro. If chlorine is there, if bromine is there, it will be bromo. If iodine is there, it will be iodo. Let me write one example. So student, here we need to keep in mind, what we have to keep in mind, how is the name, how is the structure, how a structure means this structure will replace one of the hydrogen from the alkane or main compound containing carbon and hydrogen only. That means in naming halo, this halo could be your chloro, bromo, iodo, fluoro. Okay, let me take one example. Say we are knowing that ethane, the from this one of the hydrogen have to be replaced by one of the halo group. It simply means then we can get this compound. Example, let us consider the ethane itself. We are knowing that the formula for ethane is our C2H6. It is our C2H6. This is the ethane I have drawn. But if one of the hydrogen is replaced by any of these atoms, again keep in mind the bond form will be the covalent, not an electrovalent. Though mostly fluorine, chlorine, bromine, they are able to form electrovalent like NaCl, MgCl2. But here, while it is attaching with the carbon, always the bond will be covalent, formed by sharing. So here these have to be replaced by a chlorine I am taking. So now they 6 hydrogen, it becomes 5, and along with this I need to put the chlorine. So structure is like C2H5Cl. This will be the formula. Okay, and the structure also get changed. How? This have to be replaced by now Cl. Getting? So the formula is this one, and it is called as, the name is what? See, add the word chloro here. Chloro is used as prefix, and the general name for the remaining chain is our ethane. Okay, so that we need to maintain. So add as chloro prefix and ethane. Where it is attached, before that we need to add it. It's all. Okay, similarly you can take for the other, but if the structural isomers are there, then they have the different name that we will discuss while we will learn the nomenclature, how different name are given to different structural isomers. So it is like, you can take any one. A student, can you tell me for this C3H7Br, what will be the name? Can anyone post? H7Br. And can you draw the structure? A student, very easy. Carbon, 3 remaining hydrogen, and at one place just you need to replace one of the hydrogen by bromine. It may be this end one or maybe the second carbon also, that will give the structural isomer I am putting at the end only. Okay, the name will be very easy. Br, use as prefix as bromo, and the remaining carbon is 3. So propane, it is this one. For differentiating this from their structural isomer, this is numbered as 1, this is 2. So better is to put 1 before it. That way we can write. So these are the few things that we need to understand. Let us go for the other. Okay. If we go for the alcohol, the second one is our called alcohol group. For alcohol group, the carbon compound must contain the group OH. Means OH as one of the units must present there. How is this OH? In many of the places it is also written as O bond H. It is also okay. Means this between O and H, again the covalent bond is there. For nomenclature, it is used as suffix which is attached at the end of a name and named as what? OL. This OL word have to be used. Alcohol. This OL is taken for naming. How is that? Let me take one example first. Say in this one, the same I am taking ethane. From that we are going to form the OH structure. Means alcohol we are going to form. This structure is like this. It is derived from the ethane with this alcohol. So ethane what we have to write, and this OL we have to add in giving the name. So it is ethane. The complete name is ethane. If in place of OH it were hydrogen, for considering this OH, this E have to be replaced by OL. Okay, means E have to be dropped and OL have to be written. So it is ethanol. This is the correct name. Are we getting? So it is this. This OH may present anywhere. Let me draw one more structure. Like carbon, even 4, I am attaching the OH here. All other are filled with the hydrogen. So for filling with the hydrogen, I am not going to draw the hydrogen bond like these 3 hydrogen bond at terminal carbon. Rather, these 3 hydrogen bond at terminal carbon can be written together with this carbon itself. After the carbon, you write this hydrogen. That's enough. Okay. So this way in compact form, we can write the name. How many? For this second carbon, already we have OH, means the 3 bonds are already formed. 1 bond with hydrogen will form. So write only CH. For this third carbon, 2 bonds are already formed. So only 2 other bond can be formed. So we write this, or we attach 2 hydrogen here. And with this, here keep in mind the bond is not with the hydrogen but with the carbon. For this last 3 other bonds are there. So 3 hydrogen attached is written as this one. It is this one. What is this? It is the butane, butanol. To make the structural difference, you may number it 1, 2, 3, 4. If you are numbering from this end 1, 2, 3, 4, then this 3 will be higher. So 2 is preferred. So numbering in this way is wrong, but numbering in this way is correct. More we will practice tomorrow. Okay, students? But let me write the correct name. So it will be given like this. So before this OL, we put their position ethane to OL. You have to put a dash between them. So it is butane to ol. Okay. E is dropped and OL is kept, and before that the position of alcohol group is also indicated. It is this. So it's so simple for the alcohol also. Now let us go for the other one called aldehyde. The third one is our aldehyde. This aldehyde group, contain carbon, hydrogen and oxygen, and they are collectively written like this, CHO. But how this carbon, hydrogen and oxygen are forming the bond among themselves, in addition to one of the open bond which will be attached with the other carbon chain in the organic compound. The structure is like this one, or the detail or structure is like this one. This carbon is open for the other carbon chain, but this hydrogen is attached at one end, and oxygen, you are knowing, for completing the tetravalency of this carbon, oxygen have to form double bond with this, so that both oxygen and tetravalency of carbon is gets completed. So this is the complete structure of our aldehyde. But we have to keep in mind this structure have to be kept together. You shall never change this hydrogen. I mean, you need not remove this hydrogen with the other carbon chain. So combination is not with this hydrogen. This hydrogen is inherent part of this one. Students, whether you draw this hydrogen in horizontal or in vertical, both mean the same thing. So see, hydrogen, if you are putting at the other position, oxygen will come here. Keep in mind, double bond always with the oxygen and single bond with the hydrogen. Otherwise, there will be violation of their valency rule. So whether you write this structure or simply in compact form, the first structure as CHO, all mean the same thing. Everything will represent the aldehyde. Okay, student? So these are the three ways of writing the aldehyde in a molecule. For nomenclature, we are using the suffix like alcohol, where we were using the OL. In this case, we are using the suffix AL. Okay? A student, here the important thing is always numbering start from this carbon itself. So for naming the compound containing aldehyde, this is the first compound counted for nomenclature. So it is the first carbon counted for nomenclature. How is this? Let us take one example and then draw it. A student, this open valency, it will attach with either hydrogen or with the other carbon. So let us take one example. If we are going to place hydrogen at this open, this is the aldehyde, placing the hydrogen here. Okay, it is also the organic compound. Means in compact form it is written as CHO. If you are writing this as C2, sorry, H2CO, H2CO, it gives a wrong impression. So the best way of denoting is this one. So the structure of the functional group have to be maintained. Do not club this hydrogen with this one. Though by molecular formula wise we may consider this is also okay. But the best practice is to write all the atoms in particular functional group together. So always write this functional group as one unit. Do not merge the hydrogen of OH like here. Do not merge like, means the structural formula for this, the molecular formula is our C2H5OH. Do not write this as C2H6O. No, this will give a wrong notion or wrong kind of representation, because it may be possible to form the ether or other functional group isomerism. Like a structural isomerism, it may be possible that one functional group may be changed to the other one in their isomers. Those things are beyond to your scope. So that's why I'm not discussing this thing. Okay, but keep in mind this thing. So maintain this unit. So the way of writing is this, and this is containing how much carbon? Only one. So the simplest carbon contain and hydrogen containing compound is our methane. So it is derived from the methane. So ANE, so this E have to be replaced by AL. So the name is methanol. Okay, but if you are taking like this, say C with the 3 carbon CS3 OH, it become methanol. Okay, so from methane even we can derive by replacing one of the hydrogen by any of the functional group. If we have the 2, means this is going to attach with CS3. So you write this CS3 CHO. The complete structure is like this. This carbon is attached with the 3 hydrogen. This we have learned in much more detail in our last 3 or 4 classes. Every time I was writing this structure and drawing the same thing. This can also be drawn in their structural form. So double bond O I am drawing here and H. Okay, it is this part. The name is what? This is 1 and this is the second carbon. So it is derived from ethane, but it is aldehyde. So suffix is E, you have to drop by Al. So the name will be ethanol. Okay, student, it is this way. So this was our aldehyde. Now let us go for 2 more, then we will stop the class. The third one is called as ketone, or let us first go for the carboxylic acid, called as carboxylic acid. A student, their structural formula is, in compact form it is written as COOH, but in open form or with the bond form, 1 carbon attached with the oxygen and other oxygen, and this oxygen is attached with the hydrogen. So write in this form, or this carbon, because tetravalency of carbon have to be satisfied with OH. All mean the same thing. All are the same. Okay. For nomenclature, it is used as suffix, and in suffix you need to add oic acid. How this oic acid? See, ic acid is taken. Okay. But O word is also added. Example, here the same rule. This is the first carbon for nomenclature. This we have to take in mind. Means this can be attached with the hydrogen. So here it can be hydrogen or any other methyl group. Means from the methane, ethane or propane or butane, one of the hydrogen is replaced and attached here. Means from the alkyl group. So it is called as your alkyl group that I was using till now. Alkyl group. Example, let me write few. COOH is there and only one hydrogen is placed here. The formula is written in this way. This COOH, this unit have to be maintained always. Structure wise, if you want to write, it become like this. OOH. How many carbon? One carbon. So name methane. From this E you have to drop and you have to add oic acid. So the name will be methanoic acid. Okay, student? Ic and acid, there is a gap. Okay, it is like this one. If I am taking one more example, say C2, or let me take one more like this. C3H, 3 to the 6 plus 1 is 7, then COOH. What is the structure and what is the name? Those things. A student, we need to keep in mind. It simply indicate it is C3H7 is attached at the open end of this carboxylic acid group and oxygen at one end and other end OH is there. It is the functional group. Even if you want to write this carbon chain in extended form, you can write this as CH3, CH2, CH2, COOH mean the same thing. Okay, because this much part is written in this compact fashion. A structure formula wise, for that we need to satisfy the valency. So COOH, this is the functional group. This unit you need to maintain here. How I have written this? You can get this from this structural formula. Why? In the middle we have written the 2 hydrogen, and for the terminal carbon we have written this 3 because the 3 valency or 3 open bond, and if with the second carbon I have written this 2 because of these 2 hydrogens. Okay, it was this one, it was for this. Are you getting now? The other one. So we have to maintain the functional group, and the remaining can be written in compact form or in bonded form or in a structural formula form. All mean the same thing. The most commonly used structure for representation is the second one. Means always try to write, or you must prefer this structure. This structure is most preferred structure. Okay, for writing. This takes lesser space but gives more information. It is this way. What will be the name? So how much carbon is there? 1, 2, 3, 4. Naming the carbon of this carboxylic acid also need to be counted as 1, and it always present at the end. So position, giving the position 1 is even not required. In higher standard you will learn if more than one functional group, then the position of functional groups are also indicated. So it is 1, 2, 3, 4. So butane, this was the parent alkane, so E have to be replaced by oic acid. Yes, student, do it. So it become butanoic acid. So how is the structure? How is the functional group? I had explained each and everything. Now the last functional group up to your level is your ketone. Let us take the ketone. Student, ketone is the functional group which have two open bond, CO. It is like this one, and you have to draw like this. Or they simply mean one oxygen and two sides are open. Here on the either side, here we need to keep in mind, here you cannot put the hydrogen on either of these side. Why? If you are putting the hydrogen on this side, say on this side you are putting hydrogen, then it become how much? Aldehyde. So this itself is a new group or functional group that we have learned. Even if you are putting the second hydrogen at this place, also it become the methanol that we have learned. Okay. So therefore hydrogen is not possible. Here you can put the alkyl groups, means maybe of the same or maybe different, R1 and R2. Means like here you may put CH3, here also CH3 you may put, or here you are putting, in first you are putting CH3, in second you are putting C2H5. It is also okay. That's why we have written R1 and R2 may be your same alkyl group or may be different. So right here R1 and R2 may be same or different alkyl group. How is this? Let us understand. For this, name. Nomenclature of ketone is not in your syllabus, okay? But just I am going to give you simple hint, okay? It will not ask. So the term ONE, this ONE is used as suffix. How is this? Let me take one example. I'm taking the example only for the ketone. Say this is our ketone. These two ends we have to attach something. I may attach the CS3 and other CS3. It will be the simplest one. Okay. So how to number? Start numbering from one end and go to the other. So one carbon, second carbon, and it will be the third carbon. So this carbon need not be the first carbon. Okay. So direct. So it is simply called as propane. From the propane, this E have to drop and ONE have to be added. So propanone. Are you getting? This is the answer. A student, if these are different, say let me attach the different. From this side, I am attaching C2H5 and this side CS3. What does it mean? The structure is like this. C2H5 means the two carbon chain is already there. For the end, we can attach the 3 carbon, but for the middle, we can attach the 2 carbon. And then this C and O, then on this side, CS3. Okay. Hydrogen are written in compact form, student. Okay. Then how to number or what will be the name? Here we are getting 1, 2, 3, 4, total 4 carbon. You can number from 1, 2, 3, 4 from this end. The other person may also number from this end. So 1, 2, 3, 4. Then whether 3 is preferable or 4 is preferable, sorry, 2 is preferable. A student, the lower number of functional group is always preferred. That is the rule of nomenclature. So we shall write here with this 2, not with the 3. So right numbering from this end is giving the wrong answer or wrong name. So the best way is you have to just observe this functional group carefully and you have to start numbering of carbon from the terminal for which this functional group will get lesser number in count. But total 4 carbon atom is there. So it will be butane or derivative or derived from the butane. So E is to be dropped and O and E have to be added. So butanon. Now a student, even if this is coming here, that will not make any change. But better ways to indicate their name in their functional group. So just shift it slightly, write their position. Means this functional group is present as position 2. So put this 2 here and write it here. This is the name. Okay, student. Many a time this 2 is also written before the name 2-butanol. This is also okay, but the best way is this one. Getting no? It is internationally accepted or given by UPSC. So this is the best practice. Let me take one more, okay, so that you can understand it. So the third one, let us take CH3, CH2, CH2, CO, CH2, CH3. It is like this one. A student, here we are getting that I have written this CO like this, or many a time it is also written like this. CH3, CH2, CH2, rather than this carbon and this double bond, it may be written as CO. So the unit CO have to be maintained and the two different carbon chain have to be placed on the either side of this ketone group. CH2, CH3. What will be the name? Whether I shall start from left end or from the right end. A student, you are starting from left end. 1, 2, 3, 4. This carbon is coming at 4. Means the ketone group is coming at the 4th position, 5th and total 6. But from the right end, 1, 2, then this is 3, 4, 5 and 6. 6 will also be there. But here we are getting from this 3 and 4. This 3 is preferable. So 4 should not be considered. Okay, student? So you need to leave this way of thinking. So this way of counting is not acceptable. Here we are getting total 6. So it will be our hexane. E have to be replaced by ONA. The position also need to be maintained 1, 2, 3 because it is possible that this CO may be present at position 2 itself or 3 itself. So before this it is our 3. So it is our hexa 3ON. Whatever I have written are IUPAC name and this is the most acceptable or the best name that is being given. But earlier days, this a common system was also accepted. In that common system, here we are getting this ketone word was maintained. Okay? And whatever the two other methyl group or alkane group which was attached, their name was given. So here we are getting it is one of the methyl, it is other methyl. Okay, it is like this. So for giving the name, we are giving the name as methyl, not methyl. For this, we have to keep one of this carbon together and we have to give this as the name ketone itself in common nomenclature system. So that nomenclature system need not mug up or you people may get confused. So that's why please avoid that, and even that is not given in your book also. But in some reference book or from your net or somewhere else, you may get that name also. Okay, but I'm not going to confuse you people by giving those common name. This much is enough for you people. You have to learn only this much. But just for your understanding, let me write the few other groups also. The earlier 5 group are important. The 6th one, we may take the ether group or ester group, because this ester group, this we will learn in our soap and detergent. We will come across this. So this ester group, this COO, the hydrogen is open to attach with any other carbon. Means this COO, and at these two end it is open. Okay. So here on this side it could be any other alkyl or methyl or ethyl. It could be the other. But at none of the places hydrogen should be there. Hydrogen can neither be on this end. Why? You can attach hydrogen and you can absorb. Say, oh, here I am attaching even the CS3, but on this side it become what? It become aldehyde. Okay. Now if I am attaching the CS3 on left end and attaching the oxygen with another, means this end, now I am attaching this hydrogen. What this? This is the carboxylic acid. Carboxylic acid. So hydrogen is not possible at any place. Example, one of the example we may write. Student, we may take the CS3, CH2, C, this is attached with this oxygen, CO, and another is CS3 on this side. So here we have attached this CS3, and on the other side we have attached this C2H5. Okay, and this unit, this one need to be maintained. Here we are maintaining this. This is our ester group. This we will come across. Okay, though not grouped in your book at one place. How to name it? Nomenclature also not required for you, but you have to keep in mind whatever attached after this oxygen, that is taken as the alkyl group, and numbering always start from this carbon 1, 2, 3. So this you have to write as the ester. So it is called as methyl propyl ester. No need to write or no need to mug up. Okay, I am also not writing. Or this as methyl ethyl ester this way. So just you have to understand this kind of group is also possible. That much is enough for you. Another, the 6th one, a student, it is possible to have ether. Ether is what? Only oxygen. Again, both sides are open. It is this one, only oxygen. On this end, it could be one of the R, means it cannot be hydrogen. You cannot attach hydrogen here, R1, and here other R2. Example, say CH3 attached on one side, oxygen, then CH3 on other side. It is what? Methyl ether. Okay, so ether is this one. One group is methyl, another methyl. So methyl ether. It is like this one. It cannot be hydrogen. If you are adding the hydrogen, it become like alcohol. Okay, adding hydrogen at any of the place, it become else become what? Alcohol. This we will come across. That's why I have written this. As student, many more are there, but I am writing the very few. The 7th, nitro group. If there is nitrogen and NO2 group, NO2 or NO3 minus, that we have learned in our inorganic. But here it is not minus, it will form a bond. How is this a structure? A structure is a bit confusing at your level, but just understand this. You will say then 4 bond is formed with this nitrogen. Nitrogen attached with double bond with 1, and whatever the unshared electron present with this nitrogen, that is being given temporarily to other oxygen. Okay, so acting as bond like this. So this bond is called as coordinate covalent. So this structure is not required for you, but you just keep in mind this much. The structure is only this much. So structure wise it is drawn like this. Arrow is from nitrogen to oxygen. Example, maybe your CS3 NO2. Okay, so it is nitromethane used as prefix. This much are enough for you. A student, sulfur or thiosulfate group is also there, but other are not required. I think I have given you more than enough. So this up to ether you have to keep in mind. This will come during the reaction. Ester will also rarely will come, but nitro, thiosulfate, it is never asked and it is not in your syllabus. So it was all about our functional group. So today what we have learned? We have learned what is functional group. Functional group means the atom or group of atom which decide the characteristic, and based on that characteristic even the name is also decided. So here one of the hydrogen of alkane is replaced by this functional group to decide its characteristic. Okay, the open bond or open bond of this functional group have to be attached with the carbon or hydrogen. With hydrogen we can attach aldehyde and ketone. A student, for alcohol can be attached this with hydrogen, then this OH can be. A student, it is like this HOH, it is like our water. So this here this attachment cannot be hydrogen, that we also need to understand. It can be any of the alkyl group. Okay, this thing, but aldehyde and ketone, the open end can attach with the hydrogen also. Here we can attach hydrogen or any alkyl. It is possible to attach with any. Similarly for the ketone we have written, sorry, for the acid we have written, this hydrogen can be there or any other alkyl group. This is important, whether hydrogen can be taken or not, because questions are framed in NTSE. Ketone, both of this means two open bond, none of them can be hydrogen, so two methyl group are attached there. The nomenclature are also important up to your ketone. Okay, so this was all about this functional group. So let us stop the class here, or any doubt then please ask. Students, any doubt? Still we have gone up to the 11 o'clock. Okay, so a student, now you please try to do the blue question on page number 68 of your textbook. Please try to answer it, all the question. You please try. Okay, you have to write the structural isomers and you have to write the name. You have to draw the structure of the compound. I had already explained. You have to draw the structure and isomers. So those things please do. And tomorrow we will conduct our class. I will try to conduct or start exactly at 8 o'clock. Sometime you people are getting, or most of the time you people are getting late, since I'm trying to finish the syllabus of class